Hello everyone, myself Sheikh Muhammad Nasir. Currently I am pursuing BTech third year in CSM department at Srinivasa Ramanjan Institute of Technology. So today I am going to explain you about demultiplexer. So demultiplexer is a combination logic circuit. So demultiplexer is also known as DMUX. So it is a combinational logic circuit. So DMUX is a digital information processor. It takes input from one source and also converts the data to transmit towards various sources. The demultiplexer has one input line. The demultiplexer has several control lines. So these control lines are also known as select lines. These lines determine to which output the input data should be sent. So that is, these control lines should be determined to which output data the input data should be sent. The number of control lines determine the number of output lines. So how the in demultiplexer, if I have two selector lines, so it determines that how many output lines should there. So this is a block diagram of demultiplexer. So we have input data lines, selection lines and output lines. So it is a combination of 1 is to 2 power n demultiplexer. So there are several types of demultiplexers. One is 1 into 4 demultiplexer and 1 into 8 demultiplexer and also 1 into 16 demultiplexer. So let us see one by one. So 1 into 4 block diagram. So this is a block diagram of 1 into 4 demultiplexer. So here I am passing one input line and two selector lines, and this demultiplexer generates four output lines. So here I is a input line, S1 is a selector line, S2 also is a selector line. So S1 is the first selector line, S2 is a second selector line. So Y0, Y1, Y2, Y3. So these all are the output lines. So this is a block diagram of demultiplexer. Truth table. So here the truth tables is we have two selected inputs and outputs. So we have two selected inputs, that is S1 and S0. So here S1 and S2 is S0. If both are 0, then my Y0 will be 1. The output is 1. So the Y0 line will be blinked. So if my S1 is 0 and S0 is 1, so then I will get my output as Y1 as true and all other as false. So if my S1 is 1 and S0 is 0, so then my Y2 will be true and all others are false. So if my S1 and S0 both are 1, then my Y3 will be true and all others are false. So here 0 stands for false, 1 stands for true. So this is the truth table for 1 into 4 demultiplexer. So let's go to 1 into 8 demultiplexer. So the 1 into 8 demultiplexer was designed by using two demux. They are the two 1 into 4 demux and one into 2 demux. So the 1 into 8 demux contains two input lines and four output lines. Let's see the block diagram of 1 into 8 demultiplexer mentioned below. So this is the 1 into 8 demultiplexer. So here I have one input as a input and three selected lines and 8 output lines. So here I stands for input line, and S1, S2, S3. So these all are the selector lines. So I have 8 outputs known as Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. So these all are my output lines. So here the output will be depends on the my selector lines. If I have two selector lines, then my output will be four output lines. If I have three selector lines, then my output has eight output lines. If I have four selector lines, then my output is 16 output lines. So this is the basic information about the selector lines and this one output lines. So my output lines will be dependent on my selector lines, and I have passing one input line and three selector lines. So as to 1 into 8 demux. So it is a 1 into 8 demux. So here my input line is I, selector lines is S1, S2, S3, and my output lines are Y0 to Y7. So this is the 1 into 8 demultiplexer. So here the truth table stand here. Here it is a truth table of 1 into 8 demultiplexer. So here I am taking three selector lines, that is S2, S1, S0, and my output lines are y7, y6, y5, y4, y3, y2, y1, y0. So if my selector lines are all are false, then my output is y not only is true and all others are false. So if my selector line s2 s1 is false and s0 is true, then my y1 is true and all other outputs are false. So if my s2 is 0, s1 is true, s1 is 1, s0 is 0, then my y2 is true and all others are false. If my s2 is 0, s1 is 1, s0 is 1, and all others are false except y3, then it is the third one. So if my s2 is true and s1 s0 is false, then my y4 will be true and all others are false. If my s2 is true, s1 is false, s0 s0 is true, then my y5 is true and all other are false. So if my s2 is true, s1 also true, s0 is false, then my y6 will be true and all others are false. If my s2 is true, s1 is true and s0 is also true, then my y7 will be true and all other are false. So this is the truth table of 1 into a demultiplexer. So these all are the demultiplexer. So demultiplexer is nothing but it is a combination logic circuit. So let's see the advantages of demultiplexer. So the demultiplexer increases the efficiency of the particular communication system as it takes data from a specific input source and distributes it to different sources. The demultiplexer helps to separate the different signals from the mixed data sources. Then it distributes these data to different sources. Demultiplexer can decode the signal outputs of the demultiplexer as the system works in a reverse way of mux. So it is a quite opposite to multiplexer. Disadvantages of demultiplexer. Demultiplexer may cause a wastage of bandwidth as it distributes the defined data in different channels. These channels can overlap with each other, which leads to loss its signal. Demultiplexer may cause problems in the synchronization of signals. The data channels can overlap with each other, which leads to a delay in whole process. So these are the disadvantages and advantages of demultiplexer. So the conclusion is that demultiplexer is a compilation logic circuit. And it is a quite opposite to multiplexer. So here these are the advantages of demultiplexer, which increases the efficiency of communication. And main disadvantage of demultiplexer is overlap can be happen between the channels. So this may cause the wastage of bandwidth. So it distributes the refined data in different channels. So this is about the demultiplexer. Thank you.